All right, let's go ahead and start our notes here. We're looking at periodic trends, which is the last chapter, as you can see here, of Unit 2. We were just on the structure of the periodic table, and now we're on periodic trends. And there's 3 explore pages. If we take a quick look here at this first page, it is asking, is there a relationship between the observed chemical reactivity of an element and its position on the periodic table? If you take a look at the Explore 2, how can the observed periodic trends in reactivity of the elements be explained? So it's going to go into some detail after explaining some general trends. And if we look at Explore 3, what other periodic trends besides reactivity occur and how are they explained? All right, so we'll look at in Explore 3 some other trends. All right, well, let's go ahead and take a look at the reactivity trends here. Okay, so we're going to draw our Cornell notes. And as always, read and watch the videos. You should ideally do that before you even take these notes. Okay. In fact, I'd really suggest you pause this video and actually read it. That way, when you're listening to my lecture, the notes are going to make a little bit more sense. Okay, so essential question. All right. So let's take a moment here. Remember, I'm going to be grading you on things like summary sentences and writing what you know. Okay, so let's get this down here as well. Today is November 6th, and it's a Monday. What I already know. Okay, so go ahead and pause and answer that question, what you already know. Okay, and then let's go ahead and start with Roman numeral 1. Reactivity of metals. And we're going to start with alkali metals. Okay, alkali metals, as you recall, are all the way on the left of the group 1 elements. Okay, and what can we say here? They are the group 1 elements. And if I take my pen over here, we're talking about group 1, known as the alkali metals. And what do they include? They include lithium, potassium, rubidium, cesium, and francium. Okay, so we could go ahead and just put down here. They're going to include things like lithium, potassium, Okay, potassium has a symbol letter K. They have rubidium, or I believe that would be Ru, cesium, Cs perhaps, and francium, F. Ooh, these can get a little challenging here. Let's actually whip open a periodic table here just to double check on this, okay? Francium, Fr. Okay, cesium was Cs, rubidium was actually Rb. Rb, let's correct that. Potassium, sodium, lithium. Okay, good. We got those. And if we're looking at the periodic table here, just to refresh ourselves, this is what we're talking about. Okay, we're talking about group 1. Minus, we're not including hydrogen. Not including hydrogen. Okay, we should probably, let's see if I can get an eraser here. Not including hydrogen. Okay. Okay, these metals have similar physical properties such as low melting points and low densities. These properties make the alkali metals very soft and easy to cut with a knife. Okay, let's put this as number 2. They have similar physical properties such as low melting points and low densities. Okay. They are easy to cut. Okay. With a knife. You won't find that with most metals, will you? Okay. The alkali metals, this is also interesting, are also highly reactive when placed in water. Okay, number 3. Highly reactive with water. All right. Now, not all alkali metals have the same chemical reactivity, however. Sodium reacts more vigorously with water than lithium. Okay. So what are they saying here? Let's see. We don't lose our tool here. Sodium is more reactive than lithium. So more reactive than lithium. Potassium is more reactive than sodium. So potassium is the next one down. And potassium is more reactive than is sodium. As you go down the group, the alkali metals become more and more reactive. So they're highly reactive with water, especially as you go down the column. Okay, and remember, we are trying to understand trends, and this text is explaining a particular trend, right? And it says the alkali metals, if you take a look here, are the most reactive of all the metals, okay? Maybe that's worth writing down here. Maybe a little side note, okay? The most reactive of all metals. Okay. So you can kind of see how we're using our margin notes here to kind of draw attention to things. You're going to have some good videos here. Alkali metals, the physical properties of alkali metals. Explore the alkali metals on the interactive periodic table. That might be a simulation there of some sort. And the properties of the alkali metals. Okay, so a number of videos. So take advantage of that, okay? Okay, now here's kind of one of those weird things where Discovery Education has a repeat of text. Okay, so I think we're going to have to skip those first few paragraphs. As you go down the group, the alkali metals become more and more reactive. I think that's where we left off. Here, I like this. So this was not included, I don't think, on the last picture. Why do alkali metals have such a high reactivity? Okay, that's the question maybe you should be starting to ask yourself. Okay, they're the most reactive of all the metals. Why? Why? Okay, that's what you should be thinking to yourself. Okay, and especially in the next Explore, they're going to talk about the mechanisms. Perhaps you already have some ideas. Okay. All right, so the reactivity of metals to alkaline earth metals. It looks like we're going to move into group number 2. Okay, so we'll say this is B. Okay. And we're talking about the alkaline earth metals. These constitute our group 2 elements. Okay, and make sure, of course, you've read this. You can see I've got some highlights here. Compared to the alkali metals, these elements are harder. They have a higher melting point. And if you even jump up here, these elements are nearly as reactive as the alkali metals. We see similar patterns of reactivity as we saw with alkali metals as we go down within group 2. The further down or farther down within the group, the more reactive. Okay. We see similar patterns as we saw with the alkali metals. Those patterns were that as you go down, as we go down, they become more reactive. All right. All right. So we're going to write this stuff down here. Number 2. Nearly as reactive as group 1. Right. They're nearly as reactive. Number 3. They follow the similar pattern. Follow a similar pattern increasing in reactivity as you go down. As you go down the column. So at this point, I just want to again encourage you, what's going on as you go down the column? Okay, think about some of the things you've learned about the structure of the periodic table. As you go down, one element at a time, one line by line, what's changing? Okay, that may give us a little clue to why this happens. Okay, number 4. These are harder. These are harder metals. Okay, so they're going to have a greater density, and they have higher melting points. That means it takes a lot more heat to melt them. Okay. Okay, and let's see here. You can see that we have some images, we have some science tools, the trends of reactivity in the alkaline earth metals, about a 5-minute video there. And now we're going to move into the transition metals, okay? So let's take a look at that. Draw our line here. This is letter C. Transition metals. Also known by the American Naming Convention as the Group B elements, right? So what do these include? The lanthanide and actinide metals, okay? So they're talking about including these guys as well, lanthanide and the actinides, okay? And they go here respectively and here respectively. So they're part of this, okay? So include the lanthanide, which were your rare earth metals, and actinide elements or metals. Okay. And if we continue down, transition metals tend to be very hard and have high densities. Okay. Tend to be very hard and have high densities. Here's interesting. They also are much less reactive than either the alkaline earth metals or alkaline metals. And this low reactivity makes them suitable for making products that must resist change over long periods of time. Maybe like money, maybe like the plumbing on your house, right? Or the components in your car. All right, so let's go and write that down. Number 3. They are less reactive than your group 1 and group 2 elements. This makes them suitable for many applications. Okay, and we're drawing your attention to this statement here, okay? This low reactivity makes them suitable for making products that must resist change over long time periods, okay? Okay, now we have some videos, science tool, where they talk about the transition metals, okay? So your Discovery Education is really doing a good job of supporting you with a lot of videos to help explain these ideas. All right, so let's see here. Reactivity of metals to periodic trends. What do we know? Reactivity of metals tends to decrease from left to right. I think we saw that. Group 1 was most reactive. Group 2, the alkaline earth, were a little less reactive. And if you keep going to the right, you hit the transition metals, and they're even less reactive. So the reactivity of the metals tends to decrease from left to right. The reactivity of metals also tends to increase as you move down within a group. Okay, so let's write this stuff down here. Okay, this is almost like a summary of what's happening here, okay? So if we were to draw a periodic table, put down D, and we just draw this is your periodic table. What do we say? Reactivity decreases decreasing reactivity, let's put that down, decreases. And then what did we see as we go this way? The reactivity increased. And what are we talking about? We're talking about group 1. We're talking about group 2. And we're talking about the transition metals, right? Okay. Looks like we have a summary of metal reactivity with water, hydrochloric acid. Is that a, oh, okay. Well, so if you take a real quick look at this, this table that just seems to be here in the middle, summary of metal reactivity with water. So we've been talking about water. And we've looked at potassium, which was a group 1. Sodium was a group 1. Calcium, magnesium, did we talk about that as being a group 1, or did we talk about that being a group 2? See, there's calcium. I'll change the color pen. Here's calcium. Here's magnesium, right? So they're talking about those guys. Those are group 2 and group 2. So they're going to go through a number of these metals, and they're going to talk about the different ways that these things react, okay? Reacting with water, reaction with a dilute acid, and reaction with air. Okay, so there you go. So familiarize yourself with that and just kind of get a general sense for these different metals and their position on the periodic table as you read their reactivity, this summary of reactivities, okay? Okay, and then we have, now we're going to move to the other side. We're going to go to group 14 and 15. All right, so let's maybe do this here and go letter E, okay? The reactivity of nonmetals. Now we're talking about nonmetals. Okay, specifically groups 14 and 15. If you guys take a look here at our, if we take a look here at our periodic table, we're talking about these groups here, group 14 and group 15, okay? So we're starting to get into the non-metals, right? All right. So what does it say about that? How do the nonmetals vary in reactivity? Do they follow the same periodic trend as the metals? It's a good question, isn't it? Okay. Again, as we turn to observations of the elements, we'll find answers to these questions. So if you start with carbon as a representative group 14, this element is not highly reactive. Okay. And you can read some of the details here. Nitrogen is in group 15. In its elemental form, nitrogen bonds to one another to form diatomic nitrogen. This gas is found in abundance and tends to be nearly inert or non-reactive. Oh, this is interesting. So these nonmetals tend to be non-reactive, right? So we're talking about carbon here, non-reactive, nitrogen, non-reactive, right? Okay. Reactivity of nonmetals, groups 16 and 17. As we move to the right in the periodic table, we find that reactivity of the nonmetals increases as we move to the right. Okay, so 16 and 17 become more reactive. So here we are, oxygen is in group 16, more reactive. Moving still further to the right are the halogens in group 17. These elements are the most reactive nonmetals. Okay, so what do we want to write over here? Reactivity of nonmetals. We can say that on our periodic table, if we were to draw that out again, right, you have group 1, group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you got like 13, 14, 12, 13 all the way to 17. Let's see, we got 2 boxes. That should be fine. So this will be 13, 14, 15, 16, 17. We'll just say, and then we'll say this is like 18 over here, okay? So this would be number 13, 14, 15, 16, 17, 18. And what did they say? 13, 14, not so reactive, but as you move this way, reactivity increases. Okay. Up to 17, right? So what about 18? Do you expect that the noble gases are going to be reactive? You should think carefully because they have a full valence. The least reactive, look at that, the least reactive of all the elements are the noble gases that make up group 18. So reactivity nonmetals, reactivity increases up to group 17. Let's put a little star here. Group 18 is not reactive because they have because of their full valences, full outer valence, right? They have the maximum number of electrons in their outer valence, so they're not very reactive. Okay. Okay, well, what else do we want to say here? Reactivity in nonmetals. It tends to decrease from right to left, and the reactivity in nonmetals also tends to increase as you move up. Okay, that's a little bit, and they tell us that this is opposite to those observed for the metals. Remember, the metals, these over here on the left-hand side, the metals increased as you went down, and they increased as you went to the right, okay? Or decreased as they went to the right. And they're saying that over here, this is the opposite, okay? So let's see here. We're going to say that decreases going that direction, and it increases going up, okay? Let's get an eraser here. Increases as you go up, okay? So we can write that over here as well. Reactivity increases. Increases. What increases? The reactivity as you go up in the non-metals, okay? All right. I would pay special attention to that rule if I were you guys, okay? In summary, and now here it is. We're just, this is just going to explain everything that we've already talked about, so we don't have to really write any new notes on that. Okay, this is just summary. And that's kind of it. And then you got some homework problems. All right, so this is what I want you to do now. Let's kind of make sure we got all of our lines done. All right, go ahead and write yourself a summary sentence, okay? And we'll talk to you soon. All right, have a nice evening. Bye-bye.